Hello everyone, welcome to the another lecture of class 8 atomic structure. So myself Suman Singh. In the last class we have discussed about the arrangement of electrons around the nucleus of an atom, right? So now today we will discuss about octet rule. So in the if you have seen the previous lecture, from there you have seen that the maximum number of electrons, where what we have learned in the previous lecture from the previous video, that the maximum number of electrons in the first orbit is 2, right? And in the second orbit is 8, we have seen that, right? And the third cell is 18 and fourth cell 32, right? This one we have seen, right? But however, when we will see uh, that in the outermost cell or in the outermost orbit of an electrically neutral atom, okay, cannot have more than 8 electrons. Okay, means what? If there is, suppose this is an atom, okay, so in this atom, in the outermost cell, this there should be only 8 electron. Okay, there should be only 1 2 3 4 5 6 7 8 8 electrons in the outermost cell. Okay, and this the the outermost orbit of an electrically neutral atom cannot have more than 8 electrons. This process is called what, or this is called what? Octet rule. Okay, so what is this octet rule? Octet rule is what? According to the octet rule, in a neutral atom, okay, in a neutral atom, the number of electrons in the outermost cell should be 8. Okay, it should not exceed 8. Okay, now this was about the octet rule. Now next is one more is there, which is called duplet rule. Okay, so what is duplet rule? So duplet rule is not applicable on all the elements. Okay, duplet rule is applicable only on hydrogen and helium. Okay, duplet rule is only applied to these two elements. Other element will not follow the duplet rule. Okay, so what is this duplet rule? According to the duplet rule, the atom has only one cell. Okay, as you have seen in the um, hydrogen there is only one cell, and in the helium also there is only one cell, right? So the atom has only one cell. Okay, as in the case of hydrogen and helium. Okay, now the outermost cell can have only 2 electrons. This is called what? Duplet rule. So what we have learned, if it is an octet rule, means octet rule there should be 8 electrons in the outermost cell, but in the duplet rule there should be 2 electrons in the outermost cell. Okay, so duplet rule is applicable to only two elements, which is hydrogen and helium. Okay, but the octet rule is applicable to all the rest 116 element. Okay, the rest one, and it is applicable to the rest 116 element. Okay, so I hope you have understood this, what is duplet rule and octet rule. Once again I will repeat. According to the octet rule, there should be only 8 electrons in the outermost cell of a neutral atom. Okay, and according to the duplet rule, there should be only 2 electrons in the outermost cell of a neutral atom. Okay, so I hope you have understood this, right? Now next is, when we talk about the electronic configuration or electronic distribution, so we can understood with a better example, as it is given in your book. I will use this one only. So as you have seen, helium has only 2 electrons, right? So they can occupy the first and only the cell of the atom. Okay, they can occupy the first and the only cell of the atom, because it has only 2 electrons. As you have seen the structure, let me draw the structure here like this, right? So the helium has only two electrons, right? Helium has only 2 electrons. So these 2 electrons can be filled either in here or here, right? Only the first cell, so it will occupy only the first cell. Now again, when we talk about the lithium has and 3 electrons. Okay, 2 of which will occupy the first cell, because we know that, right, in the first cell only 2 electrons can exist, right? So 2 of which will occupy the first cell, and the 3 and the third electrons will occupy the second cell. Let me draw here, you will understand better from here. Suppose this is the nucleus, and this is the first cell, and this is the second cell. Okay, so since lithium in the first cell, we can only fill how many electrons? 2, right? So it will be 2 electrons here, and the rest third electron of lithium will go in the second cell. Okay, so I hope you have understood this, right? Now next is, when we talk about the neon. So neon has 10 electrons. Okay, so the first cell is how many electrons can accommodate? Only 2, right? And the second cell is how much? 8, right? So it will be like this. Suppose this is a nucleus, this is the first cell, and this is the second cell. So first cell will be only 2 like this, and the second cell will be 8. 1 2 3 4 5 6 7 and 8. I hope you have understood this, right? Now again, when we talk about the potassium has 19 electrons. So now, according to the octet rule, how many electrons can accommodate in outermost cell of an atom, of a neutral atom? Should be 8, right? Octet rule. So how we will feel this? We will feel like this. Suppose there is a nucleus here. This is the first cell, this is the second shell, and this is the third shell. Okay, this is the third cell. So suppose, so if in the first cell there will be 2 electrons. Okay, in the second cell there will be 8, right? 1 2 3 4 5 6 7 and 8, right? So how many it has become? 8 10, right? Now more, how many left? 9 is left. So again in the third cell there will be again 8 electrons. 1 2 3 4 5 6 7 and 8, right? Now there will be a fourth cell, because according to the octet rule, an electron in the outermost cell of an electron there should be only 8 electrons, right? So here we have already filled. In the second cell we have filled 8 electron, right? In the third cell also we have 8 electrons. So how many it has become? 18, right? But it has how many electrons here? It has 19 electron, right? So now the rest 1 electron will go here, right? So I hope you have understood this, right? So as you can see, it has already written here, a potassium atom has a 19 electron, right? The first cell will take 2 electrons, second cell 8, and rest they leave 9 electrons, which will occupy the third cell. Now according to 2n square, 18 electrons can accommodate, right? But according to the octet rule, we will follow your octet rule, okay? And then according to the octet rule, there will be an 8 electron in the third cell, and in the fourth cell, and in the third cell there will be a 1 electron, as you can see here, right? 1 electron. So its electronic configuration will be how? It will be 2 8 8 and 1. I hope you have understood this, right? For if you talk about the hydrogen, it will be 2. Helium, it will be for hydrogen it will be 1. Okay, for hydrogen it will be 1, for helium will be 2, and for lithium will be 2 and 1, right? And for sodium will be 2 8 and 1, right? Like this we will fill this. So I hope you have understood this. Now next is valence shell, valence electron, and valency. So it is a very easy thing. So suppose this is an atom, this is the first cell, and this is the second cell, or this is the third cell, like this. Okay, so the outermost, this cell, this is called what? Valence shell. Okay, this is the outermost cell. Okay, the outermost cell of an atom is known as what? Valence shell or valence orbit. I hope you are understanding this. Means what? If we are talking about this, suppose we take the example here. Suppose we are taking the example this. Okay, this one. So which one will be the outermost cell? This one will be the outermost cell. Okay, if we are talking about this, if we are taking the example of this, so which one will be the outermost cell? This one will be the outermost cell. Okay, I hope you have understood this, right? So outermost cell concept is clear, right? Valence cell or outermost cell is clear, right? So what is the valence cell or outermost cell? The outermost cell of an atom is known as what? Valence shell or valence orbit. Okay, now when we talk about the valence electron, so it is a very easy concept. Just try to understand this. Suppose we have this nucleus, this is the first orbit, this is the second orbit. Okay, so in the first orbit, as we know, 2 electrons. In the second orbit, suppose there are 4 electrons, right? So this 4, when we talk about the valence electron, so valence electron will be 1 2 3 and 4. Why it is called valence electron? Because it is in the valence cell. What I have told you about the valence electron or valence cell, valence cell is what? The outermost cell, right? So this one is the outermost cell for this atom, right? So in this atom, in the this one is, since this is the outermost cell, so how many electrons are there? 1 2 3 and 4 electrons are there, right? So the number of electrons present in the outermost cell of an electron is called what? Valence electron. Okay, so I hope you have understood this. Suppose we take the example of sodium here. Okay, so sodium has 2 8 and 1, right? In the outermost cell it has only 1 electron. In the valence cell it has only 1 electron. So what will be the valence electron? Valence electron will be 1, right? So I hope you have understood this. So it is, everything is written here, as you can see. the electron present in the valence shell of an atom is called what? Valence electron, right? The number of valence electron varies from 1 to 8, as we have already discussed that in according to the octet rule there should be only 8 electron in the outermost shell, right? So it will be vary from 1 to 8, right? And for the different for the atom of different element. Okay, now valence electron of an atom determine the valency of the element. Okay, this valence shell will determine what is the valency of a particular element. Okay, so this knowledge of atom, whatever we have learned now, this will be applicable to understand the how these molecules of an element or the compound of an element has been formed, right? From this valence shell concept or valency concept, from this concept we can easily understood what is the concept of this molecule, how these molecules are made, how these compounds are formed. Okay, from this concept we can easily understand this, right? So as we have already studied that when an atom of the same element combine with one another, okay, a molecule of that element is formed, right? As in the previous lecture we have discussed, right, that when an atom of same element combine with one another, a molecule of that element is formed, right? Now, and when the atom of different element combine, a molecule of compound is formed, right? Molecule of compound is what? For different element will, if different element will combine together, they will form molecule of the compound, and if same element will combine together, they will form molecule of the element, right? We have discussed about this in the previous class. So let us take one example. As we know that two atom of oxygen combine to form one molecule of what? Oxygen, right? As you can see. Now again, two atoms of hydrogen, one atom of oxygen combine to form a molecule of water, which is a compound, right? So here clearly you can see this is the example of molecule of element, and this is the example of molecule of a compound, right? So here is some example, right? When you see the hydrogen, this is the outermost shell of the hydrogen, and how many electrons are there? One. So in the outermost shell of an electron, and the outermost shell of the hydrogen has only one electron. In the helium you can see two electrons are there in the outermost shell, right? So outermost shell electron is, how many electrons are? It is two. In the lithium only one electron is there. So what will be the outermost shell of the electron, or valence shell of the electron? Valence shell of electron, it will be valence electron will be 1. For in this case, as you can see, beryllium, 2 electrons are there, right? So valence electron will be 2 here. In the same way for boron, here will be again 3 electrons are there, right? So it will be 3, valence electron is 3. So in this way you can see this, right? I hope you are understanding this. Now next is, as you can see, some of the things is given about the valency. So how to find out the valency? So to find out the valency, it is very easy. Valency is what? Valency is the combining capacity of the element. Okay, valency is what? Valency is just a combining capacity of the element. Okay, so how to find this valency? I will give you a simple process from where you can easily find out the valency. Okay, so suppose, as you can see, hydrogen, its symbol is what? H, right? And atomic number is 1, atomic mass is 1, number of proton is 1, number of electron is 1, right? And number of neutron is 0, because in the, as hydrogen has no neutron, and its valency is 1. So always remember that if in the valence shell of an electron there is 1, 2 or 3 electrons in the valence shell of any element, then its valency will be 1, 2 or either 3, right? If there are suppose 4, 5, 6 and 7 electron in their outermost shell, at that time the valency will be either 8 minus the number of valence electron. Okay, number of valence electron, 8 minus number of valence electron. I will let me explain you this one. Suppose we are taking the example of carbon. Okay, so carbon is atomic number is what? 6, right? So its electronic configuration will be 2, 4, right? So how many electrons are there in the valence shell? It is 4, right? So when we find out the valency, to find out the valency, just what we will do, since it has 4 electrons, so what we will do, 8 minus 4, so it will become what? 4, right? I hope you are understanding this. So again, if we talk about take the example of fluorine. Suppose we are taking the example of fluorine. Fluorine has 9 electron in there, and atomic number is 9. So what will be the electronic configuration of this? It will be 2 and 7, right? Sorry, 2 and 7. So number of outermost shell, how many electrons is there? 7, right? So valency will be valency will be 8 minus 7, which is 1. I hope you have understood this, right? So how to find out the valency? Once again, let me repeat. If there is 1, 2 or 3 electrons in their outermost shell, then its valency will be 1, 2 or 3, right? And if there is 4 to 8, if 4 to 8 is there, then at that time it will be 8 minus the number of valence electron. I hope you have understood this, right? So this was all about the valence electron and valency. Okay, in the next class we will discuss about why do elements combine to form molecules. Okay, so I hope this class you have understood, right? And here you can see some of the valencies are given. As you can see here, valencies are given, right, of different elements. Valencies are given here, as you can see, 1 0 1 2 3, like this. Valencies are given. You can find out from this formula. Okay, if 1 2 and 3 is there, 1 2 and 3 is there, then this will be the valency. And if there is 4 5 6 7 or 8, at that time it will be 8 minus number of valence electron, right? So I hope you have understood this, right? So keep up to this. In the next class we will see about why do atoms combine to form molecules. Okay, till that, thank you.